2,000 years ago, off the coast of a tiny Greek island called Antikythera, a storm sank a merchant ship loaded with treasure, bronze statues, glass bowls, jewelry bound for wealthy buyers in Rome. Divers found the wreck in 1901, and for decades museum staff mostly ignored one unglamorous, corroded lump of bronze pulled from the debris, filing it away as a curiosity. It sat in storage for years before anyone noticed it had gears. Actual, precision-cut bronze gears meshed together with a level of mathematical sophistication that has no real match anywhere else in the ancient world, and arguably nowhere else for the next 1400 years. Something built more than 2,000 years ago was doing math Europe wouldn't manage to replicate until the age of Renaissance clockmakers. And it isn't even the strangest thing the ancient world built. It's just where this list ends. It's tempting to picture ancient history as a slow, uniform climb toward modern knowledge. Real history doesn't move like that. Different civilizations, isolated by oceans and thousands of miles, independently solved staggeringly difficult problems, sometimes centuries before those problems were supposed to be solvable. This isn't a list about aliens or lost civilizations. Archaeologists and historians have studied every item here, and in several cases physically recreated the technology just to prove it was possible. What makes these inventions remarkable isn't mystery. It's ingenuity, people with no electricity, no modern chemistry, and no computers looking at an impossible problem and simply working it out, through trial, error, and generations of accumulated skill. 13 of the most jaw-dropping examples are coming up, and the strangeness only builds from here. Start with a weapon so effective it kept an empire alive for centuries, and so secret its exact formula has never been recovered. Byzantine forces first used what historians now call Greek fire in the late 7th century, during a siege of Constantinople by Arab naval forces, a liquid incendiary, projected from bronze tubes on ships, that contemporary accounts describe as continuing to burn on the surface of water. Byzantine emperors treated the formula as a state secret on the level of nuclear codes, restricting its production to a single trusted family for generations. That secrecy worked almost too well, the exact recipe died with the people who guarded it. Modern chemists have proposed plausible ingredients, but nobody has definitively reverse-engineered the original. A medieval superweapon, built well enough to terrify enemy fleets for hundreds of years, and lost well enough that we still can't fully rebuild it today. But weapons weren't where the ancient world's engineering obsession really peaked. Rome's real superpower wasn't military, it was material science. Roman engineers developed a concrete recipe using volcanic ash, lime, and seawater that didn't just survive 2,000 years of erosion. In some structures, it got stronger with age. The dome of the Pantheon, poured without steel reinforcement around 113 to 125 AD, is still the largest unreinforced concrete dome on Earth. For years, engineers assumed the durability came down to the volcanic ash alone. Then in 2023, a team of MIT-linked researchers traced the real secret to small, chalky mineral deposits long dismissed as sloppy mixing, deposits that turn out to dissolve and refill cracks whenever water gets in, giving the concrete a built-in, self-healing repair system. Modern concrete typically needs replacing within 50 to 100 years. The Romans weren't just building for their own century. They were, by accident, building for ours. Metal tells a similar story. Crusader-era knights swapped stories about Damascus steel, blades sharp enough to slice a falling silk scarf in half yet flexible enough to bend 90 degrees without snapping, forged from wood steel that originated in India and Sri Lanka and displayed a rippling pattern smiths could reproduce but never fully explain. The technique mysteriously died out around the 18th century as our sources changed, and metallurgists spent centuries afterward trying to match it. A 2006 electron microscopy study on genuine antique blades found something nobody expected: carbon nanotubes embedded naturally in the steel, formed by a smelting process invented centuries before anyone knew nanotechnology existed. Ancient smiths, without realizing it, had engineered at a molecular scale. Meanwhile in Delhi, a solid iron pillar over 23 feet tall has stood outdoors since around 400 AD and barely rusted. Metallurgists traced it to unusually high phosphorus content, which forms a self-sealing protective layer, the exact impurity modern steelmakers deliberately remove. Some of the most advanced ancient technology was aimed directly at the human body. The Edwin Smith Papyrus, an Egyptian medical text dating to around 1600 BC, documents 48 real surgical cases in clinical detail, including some of the earliest known descriptions of the brain's surface, unusual for its era in treating almost no reference to magic. Around the same period, with no contact between the two civilizations, Indian physicians working from texts attributed to Sushruta performed cataract surgery with a curved needle, plus an early reconstructive rhinoplasty using skin from the patient's own forehead, a technique modern surgeons still reference. Two unconnected civilizations, both independently deciding the eye and the skull were worth operating on with bronze tools, plant-based anesthetics, and remarkable confidence. Then there's Heron of Alexandria, working around the 1st century AD, whose devices some historians call a missed industrial revolution 18 centuries early. He built the Eolipile, a spinning brass sphere powered by jets of escaping steam, functionally a working steam engine, nearly 2,000 years before James Watt. He designed self-opening temple doors, triggered by a hidden fire that forced water through tubes to shift counterweights, convincing visitors the gods themselves had intervened, and may have built history's first coin-operated vending machine, dispensing holy water when a coin dropped in. The technology to industrialize existed in ancient Alexandria. What was missing wasn't ingenuity, it was everything else needed to scale it up. But it wasn't just the Mediterranean world solving problems nobody had asked them to solve yet. Half a world away, the Inca tackled equally impossible problems. At Sacsayhuaman, above Cusco, builders fitted 100-ton stone blocks together so precisely you can't slide a knife blade between the joints, without iron tools, wheels, or writing, construction so earthquake-resistant it still outlasts colonial buildings beside it. They also ran an empire of millions using quipu, knotted cords encoding information scholars are still decoding. Meanwhile in Han Dynasty China, astronomer Zhang Heng unveiled a bronze device in 132 AD that detected distant earthquakes with an internal pendulum, and once registered a quake the capital hadn't even felt, confirmed days later by a messenger. Two civilizations, no contact between them, both quietly reading forces nobody at the time could see. Which brings the story back to that corroded lump of bronze pulled from the Antikythera shipwreck in 1901. For decades it sat dismissed as debris, until CT scanning in the 2000s revealed what was actually inside, at least 30 precisely cut bronze gears, some with teeth just over a millimeter across, meshed together in a complex enough arrangement to model the movements of the sun, the moon, and likely all 5 planets visible to the naked eye. Researchers determined the device could predict eclipses years in advance, track the moon's irregular motion, and mark the 4-year Olympic cycle, all by turning a single hand crank. What makes this genuinely stunning, according to the historians of science who've studied it, is the gearing itself. A functioning differential gear wasn't thought to exist anywhere in the world until European clockmakers reinvented the concept in the 1600s. The Antikythera Mechanism appears to use one roughly 1400 years earlier. Nobody has found anything else like it from the ancient world, no simpler prototypes, no obvious evolutionary steps leading up to it, which means either the Greeks built a tradition of precision mechanical engineering that vanished almost entirely from the historical record, or this single object represents a level of genius that, even by ancient standards, stood essentially alone. So why shouldn't any of this have been possible? Because we imagine ancient people working with cruder versions of our own tools, slowly inching toward modern knowledge. What this list actually proves is that human ingenuity doesn't wait for permission from a timeline. Given a hard enough problem and centuries of trial and error, ancient engineers, physicians, and metalworkers again and again produce solutions advanced enough to make modern specialists do a double take. The real lesson isn't that the ancient world had secret help. It's that it never needed any. The people who built these things were exactly as brilliant as we are, just working with fire, bronze, and an enormous amount of patience. If you think one of these deserves its own full episode, or there's an ancient invention that should have made this list, drop it in the comments, because there are easily another 13 just as strange still waiting to be covered.